Hey Brandon, it's Jesse. Hopefully you can see this clearly. So for this one, you don't actually have to use an ICE table. You're gonna, because they tell you how much it's ionized. So you have Cl H2 COOH, and then that's going to ionize to Cl H2 C. Sorry, I messed up the name there. Cl CH2 COOH, and that's going to be Cl CH2 COO minus, and then a 1 hydrogen ion. Okay. So you have 11% ionization. They ask you to calculate the concentration of the acid and then the ions that it's breaking up into. This is actually an equilibrium reaction. So the formula for Ka for this one would be Ka equals the concentration of the ions, which is Cl CH2 COO minus. We don't have to balance anything because it's just dissociating, so it's 1 to 1. And then we've got the hydrogen ion on top. So products over reactants like usual. So that'll be Cl CH2 COOH, the concentration of that. So they told us it's 11% ionized, which means that if we have the 0.1 molarity of the acid, then we're going to have 11% of that is going to break up into the ions. So what that means is if we just multiply this by 11%, or 0.11, then we will get the concentration of the ions, which would be, I think it's going to be 0.011 molarity. So that's going to be the molarity for the ClCH2, COO minus, and the hydronium, or the hydrogen ion. And then the molarity of this guy is going to be, you have your original 0.1 molarity, 0.011 molarity of that is what breaks up into this. So what's left over would be 0.1 molarity minus 0.011 molarity, which would be, I think that's 0.089 molarity. So that would be your molarity of the acid at equilibrium. Now, the final part of this is just to plug those into the equation. So you would plug 0.011 in for both of the ions, and then the 0.089 in for the acid. And I'll calculate that real quick and tell you what I get. Phone is slow. I'll actually have my calculator. Okay, so I get 0.011 squared divided by 0.089. So I get 0.001359. So again, that's 0.001359, and because I believe in the question we had 3 sig figs, because there's 0.100 molarity, then we would go to 3 significant digits, so we're going to have 0.0013 for our Ka. So Ka equals 0.00136. So I hope that makes sense. You can just give me $5 for this. Yeah, it took me about 15 minutes. So, yep. I hope this helps. All right, bye.